Science with G. Today we'll be talking about the valence bond theory. So, for the first step, we'll have to write the orbital notation of the central atom's valence electrons. So, the central atom so we're talking about the arsenate atom, and the central atom has about so this is the orbital notation: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3, which is equal to 33. That's the total number of electrons present in arsenate. If you do the calculation, which is 5 plus 6 times 4, which is equal to 5 plus, so 5 is the number of electrons present in arsenate. Arsenic and oxygen has 4 electrons, and has 6 electrons, and it has 4 pairs, as you can see. So this was 24, so 5 plus 24, which is 28, and then 28, and then we have a negative 3, which we add over here, so it totally becomes 32. Then the number of single bonds that we have. So next we need to count the number of single bonds from the structure. So if you look at the structure, we can see that we have 1, 2, 3, 3 single bonds, 1 double bond, and we have 0 lone pairs. So lone pairs are equal to 0. Now this is the orbital diagram of the orbital notation. So as you can see, 1s2, 1s with 2 electrons up and down, 2s2, 2p6, 1, 2, 3, 4, 5, 6, 3s2, 3p6, 4s2, 3d10, where we have 10 electrons and 5 boxes. Then we have 4p2, 4p3, sorry, so 1, 2, 3. So, and then so we need to leave the same number of half-filled orbitals as the same number of single bonds. So we have 3 single bonds. That means we'll have to leave 3 half-filled orbitals, and then we need to place the other electron outside of the hybridized orbital to create a pi bond. So we have an extra electron which we keep outside of the to create a hybridized keep outside of the hybridized orbital to create a pi bond. Next, so we join them together to form a hybridized orbital. This, as you can see, is a hybridized orbital, and we name it sp3. And so that is the valence bond theory. And thanks for tuning in, guys. You can screenshot this part of the video, and I'll see you next time.